I was like, am I going? He's like, well, I can put you on the list. Yeah. I was like, what did you do? I did. Do you have any, the car you used yesterday? Are those all your pennies?
All right. So if we did one and we did two, then I guess, and we did three, that puts us on number four. So, since I assume / hope that Brady and Aiden and Cooper and Blair will be watching this, I'm going to try to be on my best behavior. So let's try to not make this, let's try to be efficient. Number four, what do we do first?
Answer.
Thank you for saying that out loud. Yes, factoring is the right answer. So quit your yip yapping over there. So we're going to factor the top of this one, and it's going to be x minus 1, x minus 4. And then we're going to factor the bottom of it, and that's going to be, let's pull out a -2. And that's going to leave us with x squared. Change the sign, 7x, change the sign, 12. Did I? Huh?
Oh, yeah, okay, never mind. I see what you're doing. There's a -24.
So I changed it to plus 12. Because I pulled out a -2.
We don't, yeah, any. Oh, we don't. We have a minus blank.
Are you serious? Holy snapdragons. There's a 24 there. It's right. You can see it on mine. It's like the printer said, no thanks. It did it on another one too. It did it on, you guys see that handwritten ghetto looking 8 on number 2? Did you even notice that ugly 8 on top of the, did you have a missing 8? Oh, what is going on? Okay, never mind. There's a 24 there. So anyways, fix it. And then when we pull out -2, we're left with, this is going great so far. Then we're left with x squared minus 7x plus 12. And now we're going to keep factoring. So we're going to finish it out with, it's going to look like this. We're going to have -2 times x minus 4 times x minus 3. So if you didn't, there's no way you've been here and didn't get this memo. You have to factor. That is step one. I guess if you wanted to make a case that, wait, no, I want to go find my horizontal asymptote, you could win that fight. But like factoring is just what we should do. So now we're going to go through our list of to-dos, and I think we're just going to keep doing it in the same order. So horizontal asymptote, where's it at? Y equals something, but it's not 0 this time. It's -1/2. Good. And the reason there, Layla, is because you'll notice that the numbers, so first off, the degrees are both 2, x to the 2 and x to the 2. So then that's when we defer to the numbers in front of the x squareds. There's a 1 on top and a -2 on bottom. So we make a fraction out of those, right? So horizontal asymptote is at -1/2. Are there vertical asymptotes?
Yes.
There is just one, right? Because these x minus 4s are going to cancel out. So there is one survivor on the bottom with an x in it, and it's that x minus 3. So where's the vertical asymptote at? +3. Good. Which leads us, I think we've been doing x-intercept next. If you come up with some other order that you like to do these in, it doesn't matter. I think this is just the one that we've kind of started grooving in. So what do we do to find an x-intercept? Make the top equal 0 post-reduction. And the only number that can make that happen is 1. So there's an x-intercept at 1, 0. And then, of course, we're going to look for the y-intercept. And that will exist where whatever you get when you change all the x's into 0. So I really should have a post-reduction function up here. So it really looks like this, x minus 1 over -2 times x minus 3. It's good to have this laying around. So if you change all those x's into zeros, on top you get -1, and on bottom you get +6. So it's -1/6. So the y-intercept is at 0. -1/6, and that leaves us with holes. And are there any? There is. And where does it occur? At 4. And we pause after that kind of awkwardly, like for what? And that's on purpose because we don't know how to answer that yet. And where do we put the 4? In the post-reduction function, right? And so if you put 4 in place of all the x's in the post-reduced one, you get 4 minus 1 is 3. 4 minus 3 is 1. -2 times 1 is -2. So that's at three halves. You could also call it -1.5 if you're into that kind of thing. I kind of like mixed numbers for places I have to go to. And that concludes the initial like setup work. And now we go and we graph. So horizontal asymptote is at -1/2, which I need to move that down a little bit. About there. And then there's a vertical asymptote at 3. And that concludes the skeletal structure. There's an x-intercept at 1, 0. Never a bad idea to just plot that thing in there. So go to 1, 0, stick an intercept right there. There's a y-intercept at 0, -1, 6. And I mean, I can zoom in, but what you want to try to show is that that y-intercept is just a skosh below 0. And then that really generates enough of an image now for us to be able to say, yeah, I can make a graph. So we could sketch in there's a hole. We should probably put that, huh? So if we go to 4, 1, 2, 3, 4, and then down 1 and 1/2, there's going to be a hole right there. If I zoom in a little bit, you can maybe get a better look that is actually a hole. And that's it. That's all the information we have, but quite frankly, it's all the information we need. At this point, we could just conclude the problem, sketch the graph, and we're done. And that's, we felt this way before this year. The hardest part is making the graph, and I'm just going to YOLO it and not worry about perfection here. So that's good enough. And then the graph going this way is going to be, oh gosh, Jeremy, dork. And oh, so that one went for a ride. Okay, sorry. Any questions about that? Ellen, are you just glaring and marveling at the ugliness of my graph? You're looking at it almost incredulously, as like, does that thing really exist?
Oh, it looks great.
Oh boy. Let's head to number 5. So let's factor. On the top, that's top's old school factoring. That's just going to be x minus 4 times x plus 3. Bottom is one of those annoying ones where we kind of have to pull something out before. Actually, this one won't be factorable when we're done. So we'll just pull out a -2 and we'll pull out an x. And then that leaves us with what's left over if I pull out -2x? X minus 3, right? Because you got to switch the sign when you pull a negative. So what goes away? Yeah, this is an odd one. Nothing dies. So we're going to have a couple of holes. Nope, we're going to have no holes. We're going to have a couple of vertical asymptotes, no holes. So let's get to it. Where is the horizontal asymptote? Same as before. It's -1/2. Again, we're in a situation where the degrees cancel each other out and we defer to the numbers in front. Vertical asymptote. Good job. So there is a vertical asymptote at x equals 3, and there is another one at x equals 0. So we're going to have one of those 6 bangers that kind of divides the plane up into those 6 regions. Next up is x-intercept. I believe we're going to have 2 x-intercepts, and we've seen this before, so we're not going to panic. Nice job. So our x-intercepts are at 4 and -3. Remember, those are just the x coordinates that go with zeros. That's what makes an x-intercept an x-intercept. Y-intercept can be found by changing all of the x's into zeros, which is 3, negative. Oh, it's undefined. Oh, of course it's undefined. We've talked about this before. I should follow my own rules. Why did I know going into this that there wasn't going to be a y-intercept?
Oh, because there's a vertical asymptote at 0.
Good for you, because the y-axis is hot lava. Very good. We've already ruled out the y-intercept and said you can't, no touchy. So I should have seen that coming. There is no y-intercept. And then lastly, holes, and we've already established that there are none of those. Because remember, the only way to get holes is to cancel stuff out. So let's graphy poo. Horizontal asymptote, same as before at down 1/2. Two verticals. 3, 0. And then really the only further information we have from here is just going to be as many points as we can get, right? And we don't have a ton. This one's not very helpful, but we a little bit. So we're going to go to the x-intercept at 4, 0, 1, 2, 3, 4, 0. And then there's another x-intercept at negative 1, 2, 3, 0. And here's what I think. As always, feel free, if you do it respectfully, to disagree with me. But based on our experience so far, I think we're safe to say that this side is going to go like this, correct? And I think we're also safe to say that this side is going to, oh God, I did it again. What is going on? God, I can't say these things don't happen because I record them. Gosh darn it. So there you go. There's my ugly graphs. Oh, that's terrible. Anyhow, the thing we don't know is what's going to happen in the middle and how do we solve that little dilemma? You got nothing. Pick points. It's the old elbow grease, roll up your sleeves, whatever expression you like. You just grind it out, find some points. So you just pick anything in there. I'd probably personally pick 1 and 2. I would do a couple just because they seem logical. So like I'm going to take 1. I'll put it up here. So 1 comma blank and 2 comma blank. Those seem logical as they're in between those two vertical asymptotes. So if you put in 1, I think that comes out to negative 3. Yeah, I feel pretty good about that. So 1, negative 1, 2, 3. So the only thing, well, let me ask you this. Big question incoming. Why can we be pretty sure that the graph is not one of these? Mm-mm. It's not that. Something else. Because there's no x-intercept in between there. We know, because we've already found the x-intercepts, that the graph does not cross the x-axis anywhere in between those two vertical asymptotes. If it did, we would have learned that earlier. So if the graph doesn't cross up through there, then we've got really no choice but to accept that, pardon the bad grammar, it ain't going up there, right? So, but just to be safe, let's figure out what happens if we put in 2. And as always, if you're struggling with this, I'm just doing, it's annoying, but it is basic math. I'm putting 2's in place of all of these x's in the function. So that is negative 2 times 2 plus 3 is 5. So that's negative 10. And then 2 is negative 4. 2, that's negative 1. That's positive 4. So that looks to me like negative 2.5. Negative 5 halves, but negative 2.5 makes more sense. And so there, that kind of fits with what we would have expected because we would have been concerned if the graph somehow shot up to the positive, then there'd be like some kind of disturbance in the force, right? But if we go right 2 and we go down 1, 2.5, then that really fits logically with where we're at. So we can make a pretty good sketch now as to the fact that the graph probably does, oh, good God, something like this. If you wanted to be a little bit more perfect about it, there's nothing stopping you from using 1.5 as an input. If you want to know a little bit more detail about how high that arch goes, that's fine. But this is a good enough sketch as far as I'm concerned. Okay, any questions there? Easy peasy, right? All right, let's do number 6. We don't have to finish all 8 if you don't want to, because I know that it can't be fun sitting around here listening to me. So number 6, let's factor. What's the top going to be when we factor it? Pull out a negative x, leaving us with minus 2. What's the bottom going to be? Good old classic difference of 2 squares. And then while we're here, we'll go ahead and give these things a little And then over to the side, we'll write our post-reduction. So our fixed function is negative x over x plus 2. And now we go through the list. Layla, I would like you to help me with this first part. I'm terrible with my asymptotes. Where is the horizontal asymptote at? It would be -1. I just wanted to make sure that after that first thing that you got that right. Good job. Horizontal asymptote at -1. Verticals. Are there any vertical asymptotes? There's a survivor. Who is it? -2. If you don't get canceled and you've got a variable in the bottom, you make a horizontal asymptote. X-intercepts. Are there any? Can I make the top of this post-reduction over here in the purple circle equal 0? If I do a 0, so there is an x-intercept at 0, 0. Y-intercept is what we get when we change all the x's into zeros. And that's, of course, going to give us 0 over something that we don't care about because it's still 0. So yet again, we find the x-y-intercept. The graph basically just goes through the origin. That's easy enough. And then for a hole, is there a hole? It is. There is a hole at 2, comma, something. And the something can be found by plugging 2 back into the post-reduced function. Holy smokes, I think you got it. That was fast. -2 over 2 plus 2, 4, -1. I love it. So it's -1/2. You feel the flow, right? Like, look at what you're doing. You're graphing some gnarly functions, but you're doing it by just like getting all the information you can and then piecing it together after that. So horizontal down here, vertical over here. X-intercept and Y-intercept are at 0, 0. That's huge to know. That is huge. And then we have a hole at 2, -1/2. So I'm going to zoom in on this a little bit. And I'm going to go right 2 and down 1/2. And I'm going to put a little hole right there. So I am pretty confident, as are you, that we have enough information that we can put this graph side like this. Oh, this is where it always goes south. Okay, hold it together, buddy. Stay on target. Ah! Okay, so there. Sorry, it's just getting worse. Okay, so there's one side. Just act like that looks better than it does. And we just need to know a little bit about the left. The question is it up here or is it down here? And how do we find out? Plug in a point, a number. I just need something left of the last vertical asymptote. -3 is perfect for this job. So I'm going to take -3, plug it into the post-reduction, which will be a +3 over a -1, which is -3. So that means if I go to -3 for an input, I get -3 for an output. And that, my friends, is all I need to know. Look at us. We're kicking some serious booty. Do you want to just make it official? Let's just make it official. Let's just finish 7 and 8, and then it'll be work time. And then I'll give you some more work time tomorrow. Everybody loves work time. Let's just do this. We didn't come here to finish 75% of the notes. Nope, not us. We're not quitters. Factor. I'm terrible at factoring. Could you help me with the top? What is that? Can't fool me. Nope. Nope. Yep. It's okay. I know that was a team effort to live to remember. What's the bottom going to be? Well, that's fine. You a little gun shy. Yeah, that's it. Thank you. Brooklyn's like, I'm not scared. I feel like we've seen this problem before. Like this feels like a flashback to something we just did a few minutes ago. Anyways, let's make it official. All right, let's do this. Horizontal asymptote. Good. Thank you,
Yeah.
everybody. Y is 1. Good. Is there a vertical? Exactly. There's two of them. There's one at 0 and there's one at -3, right? Awesome. I really appreciate you guys answering all these questions. How about the x-intercept? X-intercepts. Where are they? At 3 and
Maybe.
yes. How about the y-intercept? Fool me once, shame on you. Fool me twice, shame on me. Where's the y-intercept? There isn't one because the y-axis is hot lava. And are there any holes? No, because nothing canceled. I feel like we're going really fast now. We're doing great. You feeling it? Am I going too fast?
No, you're great.
Okay.
You're going at amazing speed.
Oh.
And I'm just having to think a little harder.
So there's a horizontal asymptote at y = 1. I'm going to graph two verticals. One of them is at 0. Y-axis is hot lava. And then there's one at -3. And now we've got our regions, and it's time to get as many pieces of the puzzle, the gifts, if you will, put into place. So I'll take those x-intercepts. Thank you very much. So one of them is at 3, 0, 1, 2, 3. And there's another x-intercept at -2, 0. So I feel like I can construct one arm, and that's about all I've got right now to go on. So I'm going to construct this one here. Like, oh, that one went so well. That made up for all those bad ones right there. Look at that thing. Here's a beauty. I can't say anything about the middle just because I don't, because remember, you can cross a horizontal asymptote. So, like, I don't know what it's going to do. So I need a little bit more evidence. What is the X value that I really, really want? -1 is money. So I want to put -1 in and see what happens. And if I put -1 in, oh boy, I get -4 times 1 over -1 times 2, which is -4 over -2, which is +2. Huge. Wow, that's a lovely bit of information, huh? So it's going to be up here. You can see from that, I think it's going to be pretty. Are you okay?
Yeah.
Are you sure? You enjoying this?
Totally.
Is that sarcasm? Oh, so I think this graph is going to go like this. It's going to go, oh,
You missed that point completely.
I know. Come on. Okay, good, noob. Let's try again.
Okay, but I still
My
don't think you sneeze.
rubber bracelet thing keeps getting stuck on the writing board, but that was pretty good.
I just started graphing on graph.
Oh, that's okay. It's just notes, right? You can tend to that as you please. And then, of course, we have to find the regions over here. And come on, you know this. We're going to put in -4 for our X value because we want to know what's going on over here, right? That's the question. Is it above or is it below? And that's what -4 is going to provide for us. So if you put in -4, you get, oh gosh, -7 times -2 over -4 times -1, which is 14 over 4, which is 3.5. And that means I can go put a happy little dot at -4, +1, 2, 3.5. And there it is. The mystery is solved. Nope. Dugan, are you loving this? It's fun, isn't it? All right, let's do number 8. 8, because 8 is great. Back to the top. I'd like you two to sort of get back in the rink and try again. How about this? I'll do you a solid. I'll pull the negative, and then you guys help me because this is the part I struggle with. Okay, so help me out. It's negative. And that, yes, I was like, what? Yes, that's very good. And then what's the bottom?
X plus three. No, yeah, X plus three, X minus three.
Difference of two squares. The old classic. Good. And eighth verse, same as the first. We factored. Now we look for things that cancel. Oh gosh, I just made a catastrophic error. I need something, but let's hold your horses. Got to pause the recording.
Okay.
Watch like it never happened. This is great. Until smoke. Oh, snap. Sorry. It is dripping on my till sparks and smoke shoot out of my computer. Okay. I'm not scared. All right, am I recording? Yep. So yeah, that was a little bit of a sidetrack. So thanks for the help on that one. And that leaves us with
A lot of things.
I don't know where did I? I'm looking for my
Okay.
oh, I spilled coffee on it, threw it away.
There's, oh.
No, you're good. So this is number 8. And so the bottom of number 8 is just a difference of squares. Oh, I already have it done. That's what that is.
Welcome back.
Okay. I'm so sorry that if I had another class like this, I would try recording again. But you're my only one, so I only get one shot. And when it's gone, it's gone. So we're gonna cross off these x minus 3s, and now we're gonna go through and do our thing. Horizontal asymptote, where is it? Good. Vertical asymptote. Good job. X-intercept. Good. You guys are cooking now because I had all that time where I was screwing around. Y-intercept. Definitely 0 something, and that is if you put in 0, I think it's negative 1/3. Oh no, it's because there's another negative up there. Why would I ever doubt you? And then there's a hole at where? 3. And then if you put in 3, you get 3 minus 1, 2. That's negative 2 over 6, negative 1/3. Good job. You guys just worked ahead and got all the correct. I thank you for that. Good work. All right, so let's graph it out, and then I can hand out your work and finally be done with this.
The coffee one?
This dumpster fire. Yeah, it's got just the top of it got coffee stain. It'll be fine. Yeah, you'll be working on it, and your dining room table will smell like coffee. X-intercept is at 1, 0. So we're gonna go to 1, 0. Y-intercept is at 0, 1/3. So we'll just estimate that. And there is a hole at 3 down 1/3. So I'm going to go right 1, 2, 3 and down 1/3, which is probably right about there. And so again, I think we have enough information to make one side of the graph, and the only mystery remaining is this is always I feel like I need to turn my board. This side is so hard to draw. The only mystery is what's happening on the west side, and for that, we're going to pick something like -4. So if I take -4 and I feed it in, I get the negative of -5, which is 5. And then I get -4 plus 3, which is -1, and that's going to be a -5. So -4, -5. So -1, 2, 3, 4, 1, 2, 3, 4, 5. And that concludes the graph. Boy, I'm glad that's over. I bet you are too. So there you go. That's how you do it. I'm going to hand out the coffee stained assignment, and we're going to work on it for 10 minutes or so. Get what we can. I expect you to maybe get a couple done, 1 done. I don't know. And we'll resume tomorrow. I'll keep this dumpster fire of a recording alive. I'll just pause it.